Hi, welcome to Abhiram IAS Academy. In our last session, we discussed about our remainder theorems and the what we can say divisibility rules and all those things. In today's session, we will continue the same thing. After that remainder theorem and all those things, our next one is number of zeros. How to find the number of zeros in the given number. Okay, so see here, usually when we will get the number, we all know in our last session we have seen when we are getting that zeros usually means when we multiply 5 with any even number. 5 with any even number, we will get a 0, right? For example, before going to that, what is number of zeros? What we consider as number of zeros? For example, if I multiply some 2050 with some 2400, what is the output I will get? Irrespective of the output, I will get a some number here and I will get 3 zeros at the end, right? Why? Because 1 0 and 2 zeros. Right? For this instance, for in timing, anyway 5 and 4 are there, we may get one more 0. But for instance, for our understanding, we will take in this manner. Okay, so now that means what? How many zeros are there for me here? 3 zeros. So the number of zeros means nothing but the zeros which we get at the end of any product. For example, the output of a product is something like this. 2405600. Then the number of zeros in this product we call here it is 2. The number of zeros here we call that as 2. The reason is the zeros which are present at the last. We will not bother about the zeros which are coming in the middle. We only concentrate on the zeros which are present at the end of the given number or product. So like this we call them as the number of zeros. Now what will happen in our case? How we will find the number of zeros? We all know that when we get zeros in the units place, while discussing the units digit concept, we came across this. What happened is, when we multiply 5 with any even number, we will get a 0, right? 5 with 4, 20. 5 6 are 30. 5 8 are 40. Like this. When we multiply 5 with any even number, we will get a 0. Okay, sir, very good. We will get a 0 when we multiply 5 with any even number. But if you observe carefully, in all the even numbers, we will have a 2, right? 4, I can write it as 2 into 2. 6, I can write this as 3 into 2. 8, I can write this as 2 into 2 into 2. So that means, here the number of zeros which we get is depends on 5s and 2s. Indirectly, the number of zeros which we will get depends on 5 and 2s. So from now onwards, we will not bother about the complete numbers or whatever the numbers which we need to have. We only concentrate on the 5s and 2s. Number of 5s and 2s. So then how we will find the number of 5s and 2s according to our requirement. For example, there is a numbers. There are two numbers. Find the number of zeros in 20 power 40 into 15 power 13. This is my question. 20 power 40 into 15 power 13. Now please see here students, before solving this problem, we already know the prime factorization, how to do the prime factorization. So we will apply the same concept here. 20 in general, what we can write as 20, if you observe carefully, 2 square into 5, right? 20. How you can write 20? 2 tens, 2 5s. So 2 square into 5. So the same thing here. 20 I will write it as like this. Into 15 I can write 15 as 3 into 5. Doing the prime factorization. By prime factorization I can write 15 as 3 into 5. Now please see, observe here, a to the power of m whole to the power of n means a to the power of m into n. So what I will get here, 2 to the power of 80 into 5 to the power of 40 into 3 to the power of 13 into 5 to the power of 13. Okay, here I have 3, but I never mind about this 3. We don't require that 3. We only concentrate on 5s and 2s. So how many 5s do I have here? 2 power 80 into 5 to the power of 40 plus 13, 53. And we don't require this 3. It is of no use. We only concentrate on 5s and 2s. Now please observe here students. How many 2s I have? 80, and how many 5s I have? 53. But a pair of, please see this one, a pair of 5 and 2 will give us a 0. A pair of 5 and 2 will give us a 0. So now please observe here carefully. With 80 2's and 53 5's, how many pairs of 2's and 5's I can make? I can make only 53 pairs. I can make only 53 pairs. Simple, right? Simple understanding. See, for example, if you have some 10 left leg shoes and you have some 6 right leg shoes, how many pairs of shoes you can make? Only 6 pairs of shoes. What about those excess means it is of no use. Similarly here also, I have 53 5's and 80 2's. I can make how many pairs of 2's and 5's here? I can make only 53 pairs of 2's and 5's. So that means the number of zeros will become how many here? We will get 53 zeros. We get 53 zeros. 53 zeros. Like this, any question. What we will do is we only concentrate on 2's and 5's. Based on this number of 2's and 5's, we will decide our final answer. Whatever the power we will have less, in general we will consider that power as our answer and we will take that as our number of zeros. We take that one as our number of zeros. Okay, good, fine. Next one. Wait for a second. We will see some more examples. Okay, this number of zeros concept, in this number of zeros concept, okay, one type of questions are based on these powers and the other one is factorials. Questions based on factorials. How we are going to deal these questions based on factorials means, please observe here students. We can do it in two ways. Now when it comes to the factorials, what is called factorial? N factorial means usually what we will do? N into n minus 1 into n minus 2 into and so on up to we reach 1, right? For example, if I want a 10 factorial, what I am going to write it as? 10 into 9 into 8 into 7 up to I reach 1. Okay, this is the meaning of factorial. Product of numbers up from n to 1. From n to 1 in descending order. Okay, now they are asking us, find the number of zeros in 20 factorial. For example, the question is 20 factorial. Now what you need to do here? You need to multiply 20 into 19 into 18 into 17 and so on up to you need to write up to 1. Am I correct? Now please observe here students. Usually in the case of number of zeros, what we will observe? We will observe the 2's and 5's. 2's and 5's. But in case of factorials, if you observe carefully, we will have many number of 2's, right? In almost every even number we will have 1, 2. A minimum of 1, 2. And in some other even numbers we will have multiple 2's also. Take for example 4. How many 2's we will have in 4? 2 2's. Why? Because we can write 4 as 2 into 2. If you take 8, how many 2's we will have in 8? 3 2's. A minimum of 1 2 will be there definitely in all the cases. So that means what I can say here is we will have many number of 2's. We will have many number of 2's. So in case of factorials, we will not bother about the 2's. We only concentrate on 5's. In case of factorials, we will not bother about 2's. We only concentrate here on number of 5's. Here on number of 5's. So we will see how many 5's are there in our given problem. Now tell me how many 5's I will have in this one. Anyway, we will have many number of 2's. I will not bother about 2's. I will only look for 5's. At 5 I will have 1. Right? 5, 10, 15 and 20. That means what I will have? I will have 1 5 here. I can write 10 as 5 into 2. I can write 15 as 5 into 3. I can write 20 as 2 square into 5. 2 square into 5. That means how many 5's do I have here? 1, 2, 3 and 4. So that means the number of zeros in 20 factorial is how much? The number of zeros in 20 factorial is 4. The number of zeros in 20 factorial is 4. Like this we will find the number of zeros. Okay, well and good, happy. We can easily get the answer. Right? Next we will see our next factorial based questions. For example, my question is 20 factorial, so I have simply done this one. For example, if my question is some 50 factorial, then how I am going to solve this one? See here, students, in 50 factorial, where we, anyway, number of 2's, we will not bother about number of 2's. Why? Because we will have many number of 2's. Okay, happy, well and good. Now come to 5's, where I will have 5's? 5 into 10 into 15 into 20 into 25 into 30 into 35 into 40 into 45 into, okay, 50. Like this I will have 5s, right? Am I correct? Now please observe here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Sir, we have 10 5s. Okay, good, super. You have 10, but it is not sufficient. We have some other 5s. Please observe here 25. I can write this as 5 into 5. So I have 1 in excess here. Next 50 I can write it as 5 into 5 into 2, sir. So I have 1 5 here in excess. So overall how many 5s I will have? 10 multiples of 5. Okay, good. One is excess at 25 and the other one is excess at 50. So overall how many 5s I will have? 12. So the number of zeros here becomes 12. Okay, sir. If my question is 165, if my question is 200, then how I am going to solve these questions? To avoid this problem, usually in case of factorials, we will divide with the powers of 5. Okay, divide with powers of 5. That means what? Please observe here. If I want to find the number of zeros at 50 factorial, first of all I will divide 50 with 5 power 1. What is the answer I will get here? 10. 50 is the, okay, 50 with 10. What is the answer I will get here? 10. Next, same 50 I will divide with 5 square. These are all quotients. These are all quotients. If I divide 50 with 5 square, what I will get? 50 by 5 square means 25. If it is exactly divisible, happy. If not also, don't worry. Simply observe the quotients. Okay, so 50 by 5 square, what I will get here? 2. Next power of 5 is 50 by 5 cube. What is 5 cube? Actually we have 125. When you divide 50 with 125, what is the quotient? We will get 0. Why? Because 50 is less than 125. So from here onwards, for all the powers of 5, what is the quotient? I will get 0 only. So I will stop my process here itself and I will write my answer as 10 plus 2, 12. 10 plus 2, 12. Now similarly, if my question is some 163 factorial. My question is some 163 factorial. Find the number of zeros in 163 factorial. Then what I will do? 163 by 5. Don't worry whether it is exactly divisible or not. We will not bother. We will only observe the quotient. Okay, as I have already told you, we only observe the quotient. So 163 by 5, what I will get? 32. 3 I will be a remainder. We will not bother about that 3. I will only write the quotient. Next, 163 by 5 square is what? 25. This is 5 square. Okay, so 163 by 5, what I will get here? 6. I will have 13 as a remainder. I will not bother about that. Okay, 25 6 are 150. So 6. Next, 163 by what is the next power? 5 cube is what? 125. So 163 by 125, what is the quotient I will get? 1. Next power of 5 is what? 163 by 625. Here, my numerator is less than denominator, right? So what is the quotient I will get? 0. So my process ends here itself. From here onwards, anyway, you will get all the zeros. So now number of zeros means what you will do? 32 plus 6, 38 plus 1, 39. So the number of zeros in 163 factorial is 39. 39. Like this, we will find the number of zeros. If it is a normal question, remember carefully, we will do the prime factorization and we will check how many 2s and 5s are there. Based on the powers, whatever the minimum power you will have, that many zeros you will have. Good, done. If it is in the case of factorials, anyway we will have many number of 2s, so we will not bother about 2s, we will only look for 5s. So in that cases, what we will do is, we will divide the given factorial number with powers of 5 and observe the quotient. Remember this one. If in some cases they will be exactly divisible. Like in 50 factorial, 50 is divisible by 5, so 10. 50 is divisible by 25, 2. So in such cases, it will be divisible. But in most of the cases, these things will not happen. Because of that reason, only observe the quotient. So 163 by 5 you will get 32, 163 by 25 you will get 6, 163 by 125 you get 1. Okay, understood? Now we will see some examples based on this concept. Now see here, what is the largest value of n such that this is 10 power n. 10 power n divides the product 2 power 5 into 3 cube into 4 power 8 into 5 cube into 6 power 7 into 7 power 6 into 8 power 12 into 9 power 9 into 10 to the power of 6 into 15 to the power of 12 into 22 power 14 into 22 power 11 into 25 power 15. Okay, This is a question. What is the largest value of n such that 10 power n divides the product? Now tell me students one thing. Any number if it is divisible by 10 power n means what? What is the 10 power n? Usually 1 and all zeros, right? N number of zeros. 1 and you will have how many zeros beside that? N zeros. For example, 10 square means what you will write? 100. How many zeros? 2 zeros. 10 cube means what? 1000. How many zeros? 3 zeros. So similarly here also 10 power n means what? Indirectly the number of zeros beside 1 is how many? Zeros. All zeros. That means n number of zeros we will have beside 1. Okay. It should divide the product. It should divide this product means what does it mean? Exactly divisible, right? So actually this question, most of the students think that this question belongs to any divisibility rule or some other thing, but actually this question belongs to number of zeros. So number of zeros which we will have at the end of this product, if that is equal to n, then obviously it is exactly divisible, right? So this question is indirectly number of zeros concept question. Okay, you need to find the number of zeros in this product. Now please observe here, only concentrate on 2s and 5s. We don't require any other number, only concentrate on number of 2s and 5s here. Okay, 2 power 5. Next 4 means 2 square. 2 square whole to the power of 8 means 2 to the power of 16. Next 5 I have here, 5 cube. Next 6 means what? 2 into 3. So 2 to the power of 7. That's it. And 8 means what? 2 cube. 2 cube whole power 12 means 2 to the power of 36. That is also fine. Next 10 means what? 2 to the power of 6 into 5 to the power of 6. Why? Because 10 means 2 into 5. Next in case of 15, 3 into 5. We will not bother about 3. We only concentrate on 5. That is 5 power 12. In 20, 2 square into 5, right? 20 is 2 square into 5. So 2 power 28 into 5 to the power of 14. 5 to the power of 14. Next in 22 we will have 2 to the power of 11. Why? Because 2 into 11. So whole power is 11. So in 25 I will have 5 to the power of 30. Why? Because 25 is 5 square. Whole to the power of 15 means 5 to the power of 30. Now please observe here students. When you observe here, by seeing the question itself we can say that the number of 2's are many here, right? So don't count 2's. It is waste of time. Simply count 5's. How many 5's I have here? 3 5's. 3 plus 6 9. 9 plus 12 21. 21 plus 14 35. 35 plus 30 65. So that means the highest value of n can be 65. Why? Because if I put n as 65, in denominator I will get 1 and 65 zeros. Anyway, in the numerator also I have 65 zeros, right? So these two will get cancelled. So that the largest possible value for n will be equal to 65. If you have any doubt, just count for 2's. How many we will have? 5 plus 6, 21. 21 plus 7, 28. 28 plus 36, it becomes 64. Here itself 70. So counting 2's is waste of time. So simply count how many 5's are there for us here. So the number of 5's for us here are 65 in number. So number of zeros are also 65. Next one. If 10 power n, this is 10 power n. If 10 power n divides 6 power 23 into 75 power 9 into 105 square, then what is the largest value of n? Similar to our last question only. So here we need to put the largest value of n. How we can put when we can have the largest value for n? If we know the number of zeros here, if we put the same number of zeros in place of n, then obviously we will have the largest value for n. So now see here 6 means what? What I can write? 2 into 3. So only I will write 2 powers. So 2 power 23. 75 means what? 25 into 3 actually. 25 into 3 means 5 square whole to the power of 9 means 5 to the power of 18. 5 to the power of 18. Next 105 square means what? In 105 how many 5's do I have? I can write 105 as 21 into 5. 21 means 7 into 3 into 5. So I will not bother about this 21. I only concentrate on this one. 5 to the power of 4. 5 to the power of 4. Why? Because 5 to the power of 2. 5 square only, right? So 2 power 23 into 5 power 20. Why? Because we know that a power m into a power n is equal to what? A power m plus n. And we also know that a power m whole to the power of n is equal to a to the power of m into n. Already we have seen these things in our last session, so that is the reason I have not written. So now 23 2s I have, 25s I have. Now tell me what is the value of n I can take here? 20. What is the value of n I can take in this case is 20. Why? Because the least power is 20, so we will take that as our answer. Next one. How many pairs of such that, okay, a comma b are possible in the number? In our last session we already discussed this one. Please go through that one once. Now see this question. See students, in this number system concept, every question will have its own backdrop, and we should solve that question in that particular way only. There is no standard procedure for this entire number system. Why? Because for each and every question the process will be different. Based on the question we will try to align with the process and we will try to solve it. So there is no specific procedure. That means they will ask only this set of questions, this set. They may ask us anything, so we should be prepared for all the things. That is the reason we are learning this one. Okay, now see here. Consider the multiplication 4 9s with ABC, and my output should be equal to what? DEF 132. My output should be equal to what? DEF 132. Okay, R digits, what are the value? Okay, right, respectively. Now please observe here, I will write the multiplication in little bit different manner. So please observe here. So you will have the first row, and you will not add anything to this one. You will have the second row, and you will have the third row. You will not add anything to this one. Okay, like this we will have the procedure. Like this we will have the procedure, and my final answer is what here? 2, 3, 1, F, E, D. This should be my final answer. This should be my final answer. Now tell me, when you multiply what number with 9 in units place, you will get 2. Why? Because the 2 will come here. Obviously we cannot add anything to 2, right? So by multiplying which number with 9, you will get units place as a 2. 9 8s are 72. Apart from that, with any digit we will not get this one. 9 1s is 9, 9 2s is 18, 9 3s 27, 4s 36, 5s 35, 45. Like this, 9 7s are 82. That means in place of C, definitely it should be what? 8. We don't have any other choice. In place of C, definitely we should put 8 only. Then only we will get 2 here, else we will not get 2. So now when in case of C, if I take it as 8, what will happen to my first row? 8 9s are 72. Okay, 7 will go as a carry and 2 will come here. 8 9s are 72. That 7 plus this 72, what you will get? 79. And you will be left with 7. Next 8 9s are 72. That 7 with this one once again 79. So the first row is filled with 7992. Now, okay, I have written it little bit separately. We will write it in a possible manner. Okay, 9 I will have here. So that, now please observe here, I will have 9. I will have 9 in this case. So I cannot add anything to 9 in the last row. Okay, we will fill the rows accordingly. Okay, I cannot add anything here and here. So I cannot add anything to 9 here. So by adding which 2 digits, I will get 3 at units place. By adding which 2 digits, I will get 3 at units place. 9 with 4. That is the only chance, right? So that means what I should get here? 4. What I should get here? 4. So that 9 plus 4, it becomes 13. And 1 will go as carry. That is the next story. Now tell me, by multiplying which number with 9, I will get units place as 4. 9 6 are 54, right? So definitely B value should be what? 6 for me here. So 6 9s are 54, 5 and 4. Next 6 9s are 54. That 5 will be there, and I will have 9 here. I will have 9 here. I will have 9 here. Next, once again 54. So what I will be left with? 59. What I will be left here? 59. Right? So next, now please observe here, 9 plus 9 is 18. Which number I should add here so that I will get 1? 21. To become 21, I should add here what? 3. Then only I will get 21, right? So 2 will go as a carry. That is secondary story. But now tell me, by multiplying which number in units place, I will get 3. 9 7s are 63. 9 7s are 63. So that means my unit place is here what? 3. Next, 7 nines are 63. I have written 6 and 3. 7 nines are 69. Sorry, 63 plus that 6, what you will get? 69. 9 and same as usual 69. So now I am left with this one in this manner. So A, B, C values I came to know it as 7, 6, 8. Now add this one 7, 18 plus 7, it is 25. So 2 will go as a carry and in place of F it should get 5. Next 2 plus 5 it is 7, 7 plus 9 it is 16. So in place of E it becomes 6 and 1 will go as a carry. So in place of D it becomes what? 7. So what will be my answer? 7, 6, 8, that means A, B, C. 765. 768, 765. Okay. Right. Please observe here where you will get 768, 765. Or else 8 7s are 70, 8 9s are. Where you will get A, B, C and D, E, F. So please observe here, in this manner we will get the answer. There is some shuffling in the options. Please check that one once, students. Or else somewhere we have done a small calculation mistake. No worries, but this is the process. Next one. Which of the following statements is not true? Which of the following statements is not true? The difference of two prime numbers both greater than 2 is divisible by 2. Now see here, all the prime numbers except 2 are odd numbers, right? All the prime numbers except 2 are odd numbers. So now see here what they are telling is the difference between two prime numbers, both greater than 2. That means all the, now our set came to all the odd numbers. Difference between any two odd numbers will be what? Difference between any two odd numbers, whether they are prime numbers or not, it is secondary. Difference between any two odd numbers will be always even number. If you have any doubt, check. 5 minus 3. What is the difference? 2. Not only prime numbers, we will take some composite numbers. 15 minus 9. What is the difference? 6. So the difference between any two odd numbers will be always even number. Even number. Now see here, both greater than 2 is divisible by 2. Any even number is obviously divisible by 2. Any even number is obviously divisible by 2. So my first statement is correct. They are asking us is not true. They are asking us which one is not true. First one is correct. Now see the second one. For two different integers m comma n and a prime number p, if p divides the product m into n, then p divides either m or n. Yesterday in our last class itself we have seen. M into n is divisible by p. P will divide the product m into n. Then obviously p will divide either m or n, right? It can divide both m and n also. Okay, then P divides either M or N. It can also divide both M and N also. Okay, next. This one is correct, but that is not our answer. If a number is of the form 6n minus 1, then it is a prime number. While discussing the prime numbers also, we came across this one. All the prime numbers can be written as 6n plus or minus 1. All the prime numbers can be written as 6n plus or minus 1. But we cannot say that all the numbers which is of the form 6n minus 1 is a prime number. A prime number. So because of that reason, this is false. This is false. Next one. There is only one set of three prime numbers, as that the gap between the two adjacent prime numbers is 2. Yes. What is the only set we have is 3, 5 and 7. This is the only set of prime numbers where we will have gap between them as 2. Where we will have gap between them as 2. Apart from this, we don't have any other pair. So this is the only pair. So here not true, right? So our answer becomes option C. Our answer is option C. Next one. Consider the following statements in respect to two integers p and q, both greater than 1, which are relatively prime. See here, students, relatively prime, co-prime, both are more or less same thing. There will be a slight difference, but we don't require that difference. In our case, we consider relatively prime and co-prime both are same. Okay, relatively prime and now both p and q may be prime numbers. They are telling us that both p and q may be prime numbers. If they are relatively prime, they can be prime, right? See, maybe he is not forcing here. He is saying that it can be prime numbers. Yes. Any two prime numbers can be obviously co-primes. Any two prime numbers can be obviously co-primes. We all know it very well. Okay. So, maybe prime numbers, that is true. Next one, both P and Q may be composite numbers. That is also true, right? May. See here 8 and 9. These two are co-primes. Are they prime numbers? No, both are composite numbers. May, right? So that is, there is chance. Next, one of P and Q may be prime and the other can be composite. Yes, that is also true. Which of the above statements are correct? All the three are correct here. All the three are correct for us here. See here students, these type of conceptual questions are very, very important. We should know the basics to answer these questions. Next one. The equality 3 power n is greater than n cube. The equality 3 power n is greater than n cube. This is a question actually. Okay. Holds when n is any natural number, n is a natural number greater than 2. We will see. See, all the options are based on natural numbers only, right? So we will do the option verification in this case. Now natural numbers means from where it will start? 1, 2, 3, 4 and so on. Counting numbers, we call them as natural numbers. Natural numbers. So first of all, in place of n, I will put 1. So what I will get? 3 power 1 is greater than 1 cube. Yes, this is correct. 3 power 1 is greater than n cube. And now we will see greater than 2, greater than 3, except 3. We have for some options right here. So I will check next one. 3 square is greater than 2 cube. 3 square is 9. 2 cube is how much? 8. This one is also true. Yes. Next 3. I will put 3. So 3 cube is greater than 3 cube. Is 3 cube is greater than 3 cube? No. 3 cube is equal to 3 cube. So in this case it failed. Now we will see the next one. 3 to the power of 4 is greater than 4 cube. What is 3 cube? 3 to the power of 4. What is 3 to the power of 4? It is 81. 81 is greater than 4 cube is 64. Yes, it is true. From here onwards, if you check whatever may be the power, that means 3 power 5. We will check one more thing. 3 power 5 is greater than 5 cube. What is 3 power 5? 243. What is 5 cube? It is 125. This one is also true. If you want to check, you can check more 1 or 2. Now please observe here. This condition failed at what position? When n is equal to 3. It is failed when n is equal to 3. Except this, it is what? True for all the natural numbers. So n is a natural number except 3 will be our answer here. N is a natural number except 3 will be our answer in this case. So students, whenever you see this type of questions, we should solve at least 3 to 4 values. We should put at least 3 to 4 values and verify it. Okay, and then only come to the conclusion whether it is possible or not. If not, don't disturb them. Understood? Next one. Consider the following statements. If P is relatively prime to each of Q and R. Okay, that means P is co-prime with P comma Q are co-primes and P comma R are also co-primes. That is the thing they are telling. Then P is relatively prime to their product. Then P is related. See, if P is co-prime with Q and R, we will take an example. We will take an example. With that we will see. Take for example, 5 is there and 6. 5, 6, 7 are co-primes, right? P is co-prime with 6 and P is co-prime with 7. Am I correct? So, sorry, 5 is co-prime with 6 and 5 is co-prime with 7. Now they are telling that 6 into 7, what it is? 42. This 42 will be co-prime with 5. Yes. When we call co-prime, if don't have a common factor except 1, that is indirectly nothing but HCF as 1. HCF as 1. So that means if they don't have a common factor, then it will not also, it won't have a common factor with its product also. It will not have any common factor with its product also. So because of that reason, the first one is true. If P is relatively prime to each of Q and R, then P is relatively prime to the product. Okay, good. If P divides the product QR, next statement is P is dividing the product QR. And if P divides Q, and he is clearly mentioning that P will divide Q, then P must divide R. Is it mandatory that P should divide R? It may or may not. Why? Because already P is dividing Q, right? So there is no rule that P should definitely divide R. It may or may not. But in question what they are telling, P must divide R. P must divide R. Is it correct? No, it is not correct. So because of that reason, I can say that only one is true here. I can say that only one is true here. Please observe your students carefully. Already we have seen this such type of things. R may be or may not be divisible. But here in this case he is telling that R should be definitely divisible. But it is not correct. It may or may not. Next one. A printer numbers the pages of a book starting with 1 and uses 3089 digits in all. How many pages does the book have? Now see here, the printer, this type of questions are also most commonly asked question. Counting of digits. We should know how to count the digits, then only it will be easy for us to get the answer. Okay, how many digits are there? Now see here, how many one digit numbers we will use? How many one digit numbers if we start with 1? 1 into 9. 9 digits, right? 1, 2, 3, 4, 5, 6 like this up to 9. How many one digit numbers we will use? 9. Now tell me how many 2 digits numbers we will have in total from 10 to 99, right? From 10, 11, 12 up to what you will write? 99. Now tell me how many 2 digit numbers I have here. How many 2 digit numbers? Whenever you count the things, students, please observe here. The process is, if you know it in general, it is fine. If you don't know, please observe here. Highest minus least. So 99 minus 10, and don't forget to add plus 1. Don't forget to add plus 1. This is a standard procedure. Okay, whenever you want to count the numbers, highest minus least plus 1. Okay, so 99 minus 10, it is 89, plus 1, it is 9. 90. So total we will have 90 2-digit numbers, or else by general observation from 0 to 99. How much you will get? Okay, or else from 1 to 99, 99 are there. Anyway, first 9 are deleted, means we will have 90 in any manner. So 2-digit numbers are how many in number? 90. So how many digits I will use to write them? I will use 180 digits. I will use 180 digits. Okay, good. How many 3-digit numbers I will have? Tell me. How many 3-digit numbers? Our 3-digit number starts from 100 and it ends at 999. As usual, 999 minus 100, it is 899, plus 1, it will become 900. So I will have 900 3-digit numbers. So how many digits I will use to write this 900 numbers? 900 into 3. Why? Because one digit I will use 3 digits. Like this 900 digits means I will use 2700 digits. If I add all of them, what I will get here? 9, 8, 8, 2. 2889. That means up to 2, to write all the 1 digit, 2 digit and 3 digit numbers. How many digits I am going to use? I am going to use here 2889. 2889. But what is the total number of digits? Actually they are using 3089. So now tell me, this excess digits were used to write which type of digits? 4-digit numbers. These excess digits were used to write the 4-digit numbers. So how many 4-digit numbers I will use here? Please observe here. 3089 is the actual number of count I am using. To write up to 3-digit numbers, up to all the 3-digit numbers, how many numbers, how many digits I am using? 2889. Just now we have got the answer, right? So when I subtract it, what is the difference I will get here? 200. That means I will use 200 digits to write the 4-digit numbers, right? To write one 4-digit number, how many 4 digits I require? 4. To write one 4-digit number, how many digits I require? 4. That means I am using 200 means how many 4-digit numbers I used to write? 200 by 4. That means I will write 44-digit numbers. Sorry, 50. 200 by 4, it is 50. That means I will write 54-digit numbers. I will write 54-digit numbers. So tell me, if you write 54-digit numbers, what is the last 50th 4-digit number? What is the 50th 4-digit number? Don't say 1050. 1049 is the 50th 4-digit number. Why? Because my 4-digit number starts from 1000. My 4-digit number starts from 1000 and my 50th 4-digit number will become what? 1049. 1049. That means he used 1049 That means he used 3089 digits to write the page numbers up to 1049. So like this, if you want to count the digits, you should go with an order: 1-digit numbers, 2-digit numbers, 3-digit numbers, and the leftover numbers will be used to write the 4-digit numbers. Sir, how you are directly went to this 4-digit numbers? Means very simple, ma. In the given options, what I have, all the 4-digit numbers only, right? That means definitely you will write all the 3-digit numbers. That is the reason initially I calculated the sum of all the digits used till 3-digit numbers. And then only I moved to 4-digit numbers. For example, if my options contains all the 3-digit numbers, then what I would have done? I would have calculated up to only 2-digit numbers. Okay, all the 2-digit numbers, and I used to find the difference between them, and if I get a value, I will divide that value with what? 3. In this case I divided it with 4, but in that case I would have divided it with 3. The reason is that is a 3-digit number. Okay, in this case this is a 4-digit number, so I divided it with 4. Next one, the number of times the digit 5 will appear while writing the integers from 1 to 1000 is. Now I started writing from 1 to 1000. I need to tell how many times the digit 5 was used. So this is also the same thing. See here students, here in this type of questions, we should go in an order. If not, we will get confused at 55, 155, 255. Why? Because in those numbers 5 will be used for 2 times. And in case of triple by 5, 5 will be used for 5 times. Okay, like this we will have some issues. To avoid all these things, we will use simply. How many times in unit digit it will be used? In units place. In units place, how many times the 5 will come for me? In units place. Please observe here. At 5, 15, 25, 35, 45, 55, 65, 75, 85 and 95. From 0 to 9. That means how many we will have? 10. So that means 10 times. But the same 10 pair will be there for every 100 pair, right? That means 105, 205, 305, 405, 505, 605 and all this like this 10 in how many times I will have these pairs? I have taken 100 as a group. 100. How many 100 groups I will have till 1000? I will have 10 groups. Okay, why? Because we will have 205, 305, 405. I mean the series. Below that we will have 215, 315, 415. Okay, like that. So like this tens, for how many times I will have 10. So that means in units place overall, how many times I will use the digit 5? I will use 100 times. I will use 100 times in units place. Okay, good, superb. Next comes to tens place. How many times I will use in tens place? Please observe here. 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, like this. How many times I used? 10 times. The same story, right? The same 10 pairs will be there in 150, 250, 350, 450, 550. That means this also I will have 10 into 10. That means overall I will have here 100. 100. You may have one doubt, sir, I have counted here and here. Here we are counting digits only. In this case, I have counted only 5 at units place. In this case, I am counting only 5 at tens place. So there is no chance to count a single value for multiple times. To avoid that confusion only, I have went with units place, tens place. Next in hundreds place. In hundreds place, how many times? 500, 501, 502 and so on up to what? 599. 500, 501, 502 and so on up to 599. So how many I will have? 0 to 99 means I will have 100 here. I will have 100 here. So will I have in thousands place? No. Why? Because my range is from 1 to 1000 only. So there is no chance to get 5 at thousands place. There is no chance to get 5 at thousands place. So my answer here becomes what? 300. My answer here is 300. So I will use the digit 5 for 300 times. The digit 5 for 300 times to write the page numbers from 1 to 1000. 1 to 1000. Okay. Next one. What is the number of 5s used in numbering a 260 page book? Number of 5s used in to number a 260 page book. So please see here as usual Tell me, solve it. Pause the video and try to solve it. Units place. Everyone, please pause the video and try to solve it. Anyway, we will discuss. In units place, what I will have? 5, 15, 25, 35, and so on up to 95. I will have 10. And how many like this I will have? I will have 10 into 2. 200 pairs up to 200. And after 200, what I will have? Up to 200, I will have 20 like this. And after 200, I will have 205, 215, 225, 235, 245 and 255. I will not have 265. Why? Because I am writing up to only 260 page numbers. So what I will get here? How many in excess? 6 are there for me here. So in units place, I will have how many times? 5. I will have 5 for 26 times in units place. I will have 5 for 26 times in units place. When it comes to tens place, please observe here 50, 51, 52, 53 and so on up to 59. Like this 10. And I will have from 150 to 159. And similarly 250 to 259 are also there in our given range. So this will be 3 in times. So this one I will get how much? 30. And can I have 5 at hundreds place? No. Why? Because I am writing only up to 260. So that means there is no chance to get 5 at hundreds place. So 26 plus 30, what you will get? 56. That means I will use the digit 5 for 56 times. I will use the digit 5 for 56 times here. Okay. Next one. Which of the following statements is not true? Okay, they are asking us which of the following statements is not true. The difference of two prime numbers both greater than 2 is divisible by 2. Okay, the difference of two prime numbers both greater than 2 is divisible by 2. Right? Already we have came across the same question earlier. We solved this one. Did we went backward? No. Okay, the sum of three prime numbers is 100. If one of them exceeds another by 36, then one of the numbers is. Okay. Now what they are telling us is sum of three prime numbers x plus y plus z is what? 100. Okay, all the three numbers should be prime numbers. If one exceeds the other by 36, then what is the number? Now this is the case. Okay, now we can do with the option verification also. There is no wrong in that. But we will see. We will see what will happen. For example, if I take one number as 17, for instance, if I take one number as 17, what they are telling is if one of them exceeds another by 36, one of them exceeds another one by 36. Okay, so that means for instance I will think that x and y have that relation between them. X and y have that relation between them. That means I will think that y is equal to x plus 36. Y is greater than x and y is equal to x plus 36. So now what I can write here? 2x plus z is equal to 100. 2x plus z plus 36 is equal to 100. Okay. So when I send 36 to other side, it will become 2x plus z is equal to what? 64. 2x plus z is equal to what? 64. 64. Now you can go with the option verification. First of all, if I assume that one number is 17. One number is 17. If the other number is exceeding with this only. So the other number becomes what? For time being, the other number becomes what? 53. The other number becomes 53. Yes, 53 is possibility. There is a possibility for 53. But if two numbers are 17 and 53, 17 and 53, what will be my third number? Why? Because sum should be equal to 100. Right? 17 plus 53 is what? 80. My third number becomes 20. Is 20 a prime number? No. So that means 17 and 53, the difference is not 36. The difference is not 36. For example, if I take one number, the other sum of other two numbers will become what? 83. The sum of other two numbers becomes what? 83. One number exceeds the other by 36, right? One number exceeds the other, and the relation between those two numbers is that 36 relation. Assume that the relation between those two numbers is that 36 relation. That means 2x plus 36 is equal to 83. 2x plus 33 should be equal to 83. Now what happens to my 2x? If I subtract 36 from 83, what I will get? An odd number, right? Definitely an odd number. What it is? 47. What happens to my x? X will become 23.5. Is 23.5 a prime number? No, decimals are not prime numbers. We will not take them as a prime numbers usually. So 17 is not my answer. 17 is not my answer. Now I will think that the other number is 29. Second option 29. If I assume that my second number is exceeding with this only as 36. 29 plus 36, what it becomes? 65. Is 65 a prime number? No, it is not a prime number. So it is not exceeding with 29. Now I will go with 29 with the other two sum. If two numbers is 29, what happens to the other two sum? Other two numbers sum becomes what here? 71. 71. 71. And one exceeds the other by 36, right? So that means what? 2x plus 36 is equal to 71. Then 2x value will become here 35. Here also the same problem. So there is no chance for 29 here. Okay, next option is what? 43. If I assume one number is 43, if it exceeds the other by 36. 43 plus 36, what it becomes? 71. Yes, 71 is a prime number. And if two numbers are 43 and 71, is it possible for us? Is it possible to get as 71? No, definitely not. Why I am not considering these two is very simple. If I think this as this one, what will happen to me? There is a 43 plus 71 itself, it will exceed 71. So there is no chance for this one. Now for example 43, I will take the other two numbers difference is 36. Other two numbers difference is 36. Now what happens to that one? 43 and the difference, the other two numbers difference as 36 means the sum of 2x plus the 36 will become what for me here? 63. And 2x value will become what for me here? 27. So x will become what? 13.5. Like this also I am not getting the answer. So here our answer becomes none of these. None of these. None of these will be our answer in this case. None of this will be our answer in this case. Now what could be our answer? What would have been our answer? Please think carefully and tell me what can be our answer in this case. What can be our answer? Verify it, you will get the answer. Please observe here. X plus y plus z is equal to 100. Okay, x plus y plus z is equal to 100. So I will think that one number is x. So 2x plus 36 plus z is equal to 100. So 2x plus z is equal to 64. 2x plus z is equal to 64. Now tell me in place of x what I need to substitute. What I need to substitute in place of x. What can I substitute? So that z also should be a prime number. Both should be prime numbers. X and z are prime numbers. X and z are prime numbers. So think carefully. For example, if I substitute 13 and 17, what will happen? 2 13s are 26 plus 17, it is not possible. I will think 23. Okay, it becomes 43, 46 and that one is also not possible. So please check that one. Okay, here the answer is none of the above. Next one. Okay, how many pairs of natural numbers are there such that the difference of their squares is 35? The difference of their squares is 35. The difference of their squares is 35. Now please tell me how many squares are there whose difference is 35? Whose difference is 35? Whose difference is 35? Please observe here students. Usually how the squares will be defined is, for example, 20 square is what? 400. 21 square is what? 21 square is what? 441. We all know it, but in general terms what we can do is, you can add 20 plus 21 to this, which is 41. Next one, 20 and 21, 41. Next, if I want to write 22 square, I should add here 21 plus 22. What is 21 plus 22? It is 43. If you add 43 to 441, it becomes 484. 481. Similarly, if I want to write 23 squares, okay, so 22 plus 23, what it becomes? 45. So add 45 to this, what you will get? 529. So in this manner it will happen. So to get the difference between two squares as 35 means, you should think in such a manner that by adding which two successive numbers I will get the sum as 35. Think that one. By adding which two numbers I will get sum as 35? Successive numbers. 17 and 18. 17, 18, 18. If you are able to identify it, happy. If not, simply divide 35 by 2. What you will get? 17.5. So 17 and 18 are the two numbers. So now 17 square and 18 square. What is 18 square? 324. What is 17 square? 289. So the difference between those two things are what? 35. 35. Like this is one pair, this is one pair. See here students, whenever you see this type of question, think that one. And one more pair will be there with 1 always. Please check whether it is. What is 35 means what? I can write 6 square minus 1, right? 6 square minus 1 square. That is 36 minus 1. That is 35. So please check with 1. They may be or may not be possible with 1. But please be careful with 1. Please be careful with 1. So 6 square minus 1 square is also 35. Verify that. And 1 will be there definitely based on this logic. Based on this logic. So how many pairs are there for us in this case? 2 pairs are there for us in this case. 2 pairs are there for us in this case. Okay. Like this we will solve the problem, students. We will see some other examples in our next session. Thank you. Hi, welcome. In our last session, we started solving some problems. So today we will continue the same thing by solving some other examples. Right? Now see here. Consider the following statements in respect to the sum s is equal to x plus y plus z, where x plus y and z are distinct prime numbers, each less than 10. Each less than 10. So here they are telling that s is equal to x plus y plus z. Okay, where x, y, z are distinct prime numbers less than 10. So first of all, please decide our final, group of numbers which we can put in place of x, y and z. What are the values I can take in place of x, y and z is 2, 3, 5, 7. Right, these are the numbers or digits I can take in place of x, y and z. These are the numbers I can take in place of x, y and z. And now, the sum of the unit digit of s can be, the unit digit of s can be 0. Can be. It is can be. Can be means if it is possible for one value also, it is okay for us. We can take with that one. Okay. If it is possible for one also, if you get one, for one set, if you get 0, that is enough. Now take that set as in such a manner we get 1. If I take 2, 3 and 5, the sum is 10. So unit digit will become what? 0. Can be. So this is correct. Next one. The unit digit of s can be 9. Can be. This one is also can be. So can we get the unit digit as 9? We will verify it once. If I take 2, 5 and 7, will I get 9? No. I will not get 9. If I take 7 plus 5 is 12. 12 plus 3 is 15. We will not get. By taking any 3 values. By taking any 3 values in units place, I will never get 9. So there is no chance. The unit digit of s can be 5. Yes, just now we have seen, right? If I take 7, 5 and 3. 7, 5 and 3. The unit digit can be 5. Why? Because can be. So here 1 and 3 are correct. Option B is wrong for us here. Okay. Next one. 3 numbers x, y, z are selected from the set of first 7 natural numbers such that x is greater than 2y is greater than 3z. How many such distinct triplets of x, y, z? First of all, tell me first 7 natural numbers. What are the first 7 natural numbers? 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and 7. Now tell me first of all one thing. Which will have the greatest value among these 3? Whether x, y or z? Very simple, z. Why? Because 3 times of z. 3 times of z is less than 2y. And 2 times of y is less than x. From this itself I can say that x will have the highest value, y will have the next value and z will have the least value. So now they are asking us that how many distinct values such that distinct triplets I cannot take for multiple times. So for example, for instance, if I take z as 1, so what are the possibilities I can have for y? What are the possibilities I can have for y? See here, I can take y as 2. Why? Because 2 2s are 4. There is a chance. Next, I can take y value as 3. If I take y as a 2, I can take y as a 3. There is also chance. Why? Because 2 3s are 6. I can take y value as a 4. There is also possibility for me. Y as a 5. We will see. Y as 6 and y as 7. I can take all the possibilities. We will check. Anyway, some will get cancelled. But for instance, if I take z value as 1, for y I will have these many chances. Now tell me, if z is 1, y is 2, what are the values of x I can take? What are the values of x and I can take? If y is 2, what happens to this one? 4. If y is 2, this 2y value will become what? 4. So what are the values of x possible for me? I can take x value as 5. I can take x value as 6. I can take x value as 7. Why? Because all these numbers are greater than 4. All these numbers are greater than 4. Okay, good, super. If y value is 3, then what happens to this 2y? It becomes 6. And what is the possibilities of x I can have? I can only take x value as 7. There is no other choice for me. If y value is 4, what is the value of x I should take? A minimum of 9, right? Why? Because if I take y as 4, this value becomes 8. So x value should be a minimum of 9. But my range is from 1 to 7. So that means from y to 4, this is not at all possible. I cannot take y value as 4, 5, 6, 7, which are not at all possible. So what are the possible pairs I have in this case? 1, if z is 1, I can take like this. For example, next pair we will see. If I consider z as a 2, we will check whether it is possible or not, then we will decide. If I take z as 2, what happens to this value? It becomes 6. Next, y value, what I can take here, tell me. In worst case also, I should take y value as 4. Why? Because then only 2 4s are 8 it will become, and it will be greater than 6. It will be greater than 6. Why? Because here I cannot take y value as 3.5. Why? Because I have only choice as this one. If I take y as 4, the minimum value of x should be what? 10 or 9, which is not in my range, so I cannot take z as 2. So the only possible pairs are, these are possible pairs for me. So what are the possible pairs do I have here? X as 5, y as 2, z as 1. 6, 2, 1. Distinct pairs. Next 7, 2, 1. Right? This is one pair. Next what I have? 7, 3, 1. So overall how many distinct pairs I can have here? 4. So total 4 triplets I can have here. 4 triplets I can have here. 4 triplets I can have here. So 5 to 1, 6 to 1, 7 to 1 and 7 3 1. So overall I will have 4 triplets. So whenever you see these type of questions, first of all please observe which one is greater and from what you should start assuming. Okay, if you take from x, it will be little bit clumsy. I will not say that you will not get the answer, but it takes some time for us. So always take the values from the least value so that you will get a perfect answer. Okay, next one. Let p and q be positive integer satisfying p is less than q and p plus q is equal to k. Okay, both p and q are positive integers. What is the smallest value of k that does not determine p and q uniquely? See students, in my previous classes I told you what is meant by unique solution. Unique solution means I should have a single value for p and q. I should have a single value for p and q. Now here very clearly they are telling that what is the value of k I should take so that p and q cannot be unique. That means I should have multiple values for p and q. I should have multiple values for p and q. I should have multiple values for p and q. Now please observe here. What we can take? P plus q as k, right? So if I take k value as 0 for time being, they clearly mentioned that p and q are what? Positive integers. Can the sum of any two positive integers can become 0? Is there any possibility? Until and unless both are zeros. Until and unless both are zeros. Okay. But the thing is p is greater than q. That means I cannot take 0, 0. Definitely I should take 1, 0 or something. In worst case also. So k value 0 I cannot take at all. Next, k value I will take it as 1. K value I will take it as 1. So positive integers, so here also that is not possible for me to get as 1. You may think 0 and 1, no ma, you should not take 0 and 1. You should not take 0 and 1. Or also, apart from 0 and 1, do we have any other choice for k is equal to 1? No. So that is not our answer. Next, k is equal to 2. If I take k is equal to 2, here also the same problem, right? K is equal to 2. I cannot take 1 and 1. I cannot take 1 and 1. That is not at all possible. See here students, 0 is neither positive nor negative. 0 is neither positive nor negative. That means, sir, I will take 2, 0 or else 0, 2. That is not possible. That is not possible. Okay, please remember this one. 1 and 1 I cannot take. Why? Because P is less than Q. P is less than Q. Okay, that is also not possible for me. If I take K as 3. If I take K as 3. Now please see here, now it is possible for me. I can take Q as 2 and P as 1. Apart from this, can I take any other values here? 1 plus 2 is 3. I cannot take any other value. Why? Because P is less than Q. So this is the first pair which will satisfy P plus Q is equal to K, 1 and 3. But it will have a unique solution, right? If K is equal to 3, definitely P should be 1, Q should be 2. P should be 1 and Q should be 2. There is no other choice for me. For example, if I take K as 4, or else if you have any such confusion, do the option verification. But for time, if I take K as 4, what are the possible values I should take for P and Q? P value, if I take 1, what is the Q value I should take? Definitely 3. If I take P value as 2, Q also becomes 2, which will not satisfy our given condition. Why? Because P and Q are not equal. So here also I have only one solution. That means unique solution. Only one pair I have, 1 and 3. Only one pair I have, 1 and 3. For example, if I take K value as 5. Now please observe here, K value as 5. P I can take 1, Q I can take 4. Yes, possibility is there. P I can take 2 and Q I can take 3. Yes, there is a possibility. So here, do I have the unique solution for P and Q? Unique means only one pair, which will satisfy only one pair. Here, I don't have a unique solution for P and Q. Why? Because I have here multiple solutions for P and Q. Because of that reason, our answer here becomes 5. Why? Because that does not determine P and Q uniquely. If the question is, it should determine P and Q uniquely, means what is the answer I can take? K value as 3. But here in this case, they are telling not determined P and Q uniquely. See students, this is the general method of approach. If you want to do with option verification also, you can do. What they are telling? P plus Q is equal to 3. That is K, right? K values are given here. So the possible pairs for me is 1 and 2. Apart from this, I cannot take any other values. Don't say 0 and 3. Sir, I can also take 0. 0 is not a positive integer. Once again, I am repeating, 0 is not a positive integer. You cannot take 0. Okay, understood? Next, P plus Q, according to the option, if I take 4, what are the only chances I can have? I can take P as 1 and Q as 3. Sir, I can also take 2 and 2. No, you cannot take 2 and 2. Why? Because P is less than Q. Here also I have only one pair, that is 1, 3. So this is not my answer. Next, P plus Q is 5. So P value 1 I can take, Q value I can take 4. Yes, there is chance. Next, P value 2 and Q value 3. Yes, there is chance. So there are multiple solutions, right? Not a unique solution. I have here 2 solutions. So here my answer becomes 5. So 5 is the least number of K. Like this we will have many numbers, but the least one among them is 5. Okay. So which will satisfy the given condition for us here. Okay, understood? Next one. What are the values of unique values? Please see here. What are the unique values of X and Y? That means X and Y, you should say exactly a unique value. Where X, Y are distinct natural numbers. They are clearly mentioning that X and Y are not equal, and X and Y we should tell a unique value. Now, X by Y is odd. They are telling that X by Y is odd. With this one statement, can we tell the answer? See, this type of questions. Please observe the first one. They are simply saying that x by y is odd. X by y is odd. You will get multiple answers, right? For example, 15 by 3. What is the answer? 5. 15 by 5. What is the answer? 3. Like this, we will have many pairs. Can we tell a unique answer with this one? It can be any numbers, right? X and y can be any numbers. Whose mean? When we divide each one with the other one, its value should be an odd number. Like this, we will have many numbers. So with statement 1, I cannot say exactly that x is some value, y is some value. Why? Because I can get multiple values here for x and y. So with only statement 1, I cannot tell my answer. Now see the second statement, xy is 12. Xy is 12. So what are the possibilities of x and y I can have? 1 into 12 is 12. 1 into 12 is 12. Next, 2 into 6 is 12. Yes, that is also correct. Next, 3 into 4 is 12. That is also correct. Next, right. So I have how many chances for x and y here? 3 chances. From here, can I tell uniquely my x value is so and y value is so? From here also I cannot tell uniquely. So by using statement 2 alone, can I tell my answer? No, I cannot tell. Now I will combine both the statements. That means statement 1 and statement 2. And I will check whether I can tell my answer or not. Now see here, from statement 1, what is telling? X by y is odd. Now tell me, by taking which numbers I can get x by y as an odd number here? By taking 2 and 6. If I take 2 and see, 1 and 12, if I take 12 by 1, it is 12 an even number. Or 1 by 12 is a point. I will get the answer in decimal. So it will not come under odd numbers category. Odd numbers and even numbers are purely for natural numbers, in some cases for integers. But we never go for decimals. Okay. So this is not a possibility for me. 3 by 4 is not exactly divisible. So here also we will not get an odd number. But 6 by 2. What it is? 3. It is satisfying the odd number and its product is 12. So by combining these two logics, I can come to one conclusion, right? What is that conclusion? X and y are what? X and y are what? I can take x value as 6 and y value as 2. With the help of first and second statement, I can say uniquely that x value is 6 and y value is 2. That means our answer becomes what here? The question can be answered by using one statement. Okay, no. The question can be, okay. The question can be answered by using both the statements together. Definitely I should use both the statements together, but cannot be answered using either the statements alone. Yes, I cannot answer if I use them individually. Definitely I can answer them if I combine those two statements. Okay, next one. Right. A question is given below followed by two statements 1 and 2. Consider the question and statements. Okay, question is, what are the values of m and n where m and n are natural numbers? Where m and n are natural numbers. Where m and n are natural numbers. A question is given followed by two statements. Consider following. What are the values of m and n where m and n are natural numbers? They are asking us where m and n should be natural numbers, where it is possible for us. Now, first statement, m plus n is greater than mn and m is greater than n. So with that, can we come to one conclusion? What is our answer? M plus n will be greater than m into n. So let us take some random examples, and they clearly mention that m is greater than n. M is greater than n. So I will take m value as 2 and n value as 1. 2 plus 1 is what? 3. 3 is greater than 2, right? Why? Because m into n is 2 into 1. There is a possibility. Next, like this, if I take 3 and 1, 3 plus 1 is greater than 3. So definitely m value is greater than 3. That means m plus n is greater than mn. That is also possible. So here, by using this first statement, can I tell exactly what is the value of m and n? No, I cannot tell the exact values of m and n here because I am getting multiple answers here. Okay, now I will see only the second statement. The product of m and n is 24. Now the product of m and n should be what? 24. So what are the values I can take to get a product as 24? I can take m value as irrespective. Now don't consider m should be greater than n. It can be anything. Why? Because now we came to our statement 2. So by multiplying which two numbers I will get 24. 1 into 24 I will get 24. 2 into 12 I get 24. 3 into 8 I get 24. Right? Or else 8 into 3 or 3 into 8, 12 into 2, whatever it is. Next 4 into 6 we will get 24. Like this we will have multiple chances. Like this we will have multiple chances for M and N. So by using statement 2 alone, I can tell my answer. I cannot tell my answer. What are the values of M and N? Now I will try to combine these two statements. My first statement and my second statement. My first statement. Now please see here. Now I will substitute these values in my first statement and I will try to verify. M plus N will be greater than Mn. M plus N means what? 24 plus 1 is greater than Mn. That means what? 24 into 1. So 25 is greater than 24. This one is correct for me. 25 is greater than 24. This one is correct for me here. Next, if I take 12 and 2. If I take 12 and 2. So 12 into 2. Sorry, 12 plus 2. 12 plus 2 is greater than 12 into 2. 12 plus 2 is what for me? 14. Is 14 greater than 24? No. So I cannot take 12 and 2. Next I will take 18 and 3. 18 plus 3 is greater than 18 into 3. So this one is also not satisfying for me. Why? Because 18 plus 3 is 21. Is 21 greater than 54? No. That went wrong. Next 4 plus 6 is greater than 4 into 6. 4 plus 6 is 10. Is it greater than 24? No. So the only possibility for me is 24 and 1 pair. 24 and 1 pair. So by combining these two logics, I can say that M value is 24 and N value is 1. M value is 24 and N value is 1. Definitely I can say that M value is 24 and N value is 1. That is the only thing which satisfies these given conditions. So with the help of both the statements 1 and 2, I can tell my answer is 1 and 24. That is M value is 24 and N value is 1. With the help of both the statements. So the question can be answered by using statements together but cannot be answered by using either alone. So in this manner you need to solve the questions based on statements. See, definitely please observe this type of questions. You can expect a minimum of 1 to 2 questions from this area. Definitely. How you are solving the problems, you should know the basics. That means what you consider it as natural number, what is called positive integer, what is called negative integer, okay, and conditions, how you need to put the values. Okay, first by taking the first statement, I will have multiple chances like this, all with 1 only. Actually speaking, it will be possible with 1 only. 4 plus 1, 5 plus 1, 6 plus 1. Without having 1, this condition will not get satisfied. But like this, I can use for all the numbers with 1, right? Because of that reason, we are having multiple choices. Next, second one also we have some 4 chances. But when I combine these two logics, I got only one answer. That is 1 and 24. So that means by using both the statements, I can tell my answer as M as 24 and N as 1. Because of that reason, we will take both the help.